Okay, so just let me briefly go back so that the people who just started watching this will understand. So we're talking about the problem, the challenge for the week 6, and we're discussing on that. And the main question we want to answer first is that, okay, what are the elements we're gonna do? But before that, I asked a question where what is the difference, the distinction between the data science goal and the business goal, and what are the key factors that distinguishes these two elements, these two goals, which such that it will guide you what to follow and what to talk. The one part will just, when it's a data scientist, knowing the business objectives really gives you an ability, a way to talk to the business people, while the data objectives allows you to go through your analysis. So, and then the discussion we have right now is like on that, what are these key factors and how people understand. And so Biniam, continue.
Yeah, okay. So, as I was saying, actually, we don't have much to add on what Elvis said. So, as a data scientist, we might be interested in features that can result in very accurate models. For example, when we do the EDA, we might find out that some features are have a very a very suitable correlation with the target value we're trying to predict. But from the business perspective, those features might not be as important for the final prediction. So in that case, we're just gonna have to go with developing a different model that incorporates all the features that are very important for our business objective. So I think that's the difference.
Mm-hmm. Okay. So who else want to chip in? I think what Elvis said just earlier and what Nahum said before are very much, of course, it's about general insight and getting the business objective is more a longer term, a vision part of it. But the data objective in this particular case, so Elvis was saying, like in the bank case, for example, they want to find out who are the people who deposit, while in the business, in the data science objective, we want to create a model that will allow us to predict that. I mean, these are really, yes, true, but what else can we get more out of it, like in terms of the differences? Like the key factors, key other differences in these two objectives. Okay, so to mention one, for me, the one of the other key that you shouldn't forget is that the business objective, when it's formulated, it's based on a problem, based on profits and things, solving a problem that would has some kind of KPI. So in this case, the key performance indicator is that they want to improve their revenue, right? And they don't care who does it. It could be a voodoo, a magic. There could be another company that does a service and they do it through some other form, not data analysis, but maybe they have another new technique, that they develop. They don't care. Partly what they really want is an answer, like a way, a surest, a secure, of course, a guaranteed way that, repeatability is important. So kind of they adopt, of course, as a principle, they may have they adopted maybe certain principle in their mission, which is like they want to be, I don't know, environment friendly. They don't want to pollute like that, but also they don't want to have like some kind of other issues with respect to how the way that it continues. But within that principle, they want anyone. It could be through marketing, it could be through anything else, right? They just want to see an impact or a solution that will increase the revenue. And there are probably many competing ways to do it. One is through just a pure marketing that you derive actually more of, instead of spending more money to produce model on predicting precisely what if the user does that or not, you can actually spend more money in getting the marketing strategy right. So there are multiple places where you do data science actually. And so as a data science, like before the data science, there was a choice that was being made. Who's gonna do it? Or even in which part of the element is the data science team gonna involve? It's like, is it gonna be in predicting the user's likelihood to term deposit, or is it gonna be in kind of finding, I don't know, getting more people to subscribe to our company such that, you know, then we increase the term deposit? So there are multiple ways of achieving the same thing. So the data science team, or the data science part, partly combined with the decision makers, is finding out that. But once that's defined, in this case, let's say it's about predicting the user, but that's not obvious, you know. It's like, if you think of it, it's not really obvious. There had many, it's called a funnel. There are many places where you could do improvement in the funnel, from the advertisement to charging more. You know, Apple and Google, or Apple and Windows, has been exactly another way. One charges a lot to make profit, another spreads the, you know, make it cheaper and kind of make it earns money more by a lot of people subscribing. So there are multiple strategies, and so there one strategy is chosen. Let's imagine in this case it's about predictive modeling of high likelihood a user. This is the same as in marketing strategy. In the kind of last, I think the week before, the A/B testing where you did was, okay, it's about finding the creatives that most people have, most people who could see the creative kind of respond, or they have high brand awareness, right? So in that case, you could have improved either the creative, or you could have improved in finding people who actually would engage more. So I do, for example, in the algorithm development, I do the other side, which is like finding people who would engage more. But, and then I have another team just that I allow them to do also, improve. It's called recommendation engine team, that who just recommend what creatives are performing better. So they do ADA to do this kind of things, and elements of it, right? So there are many funnels, parts of the funnel that you improve. So that is the difference. Once then you come to the data science part, in this case, the EDA, like this, what you're going to do, the kind of predictive analysis, then you start defining for that particular part, you start defining the data science objective, which is like how you're going to go through it. So then you start really caring about these features, engineering, class imbalance. But that all was not necessary for the business people. They didn't care, and they don't care sometimes. And that's where I was saying earlier that understanding these key differences allows you how to talk to the business, because the business didn't care in the first place if you do it this way or the other way. You could have done it, actually improved it in the, basically in targeting, in marketing. They would have listened to you the same way. For them, it has no difference whether you do it this way, whether that you do it that way. They make sure that you of course do it the right way, like but so then that's why you don't have to bother them too much about how you did that, because it's cool. But you kind of really tell them the essence of it. The essence is like to make it clear for them why this choice that you are doing is more important than, for example, in another part, which is in the marketing. You have to justify that really doing this is more important because, it improves this much amount with respect to that. So you kind of really will create a story or a narration that allows you to do a better communication in such a way that you get the ear of the decision makers, right? The CEOs or the CFOs, whatever. So that's where I would say this distinction is very important. And then once you get in, you zoom in, now you're doing, then you have to define clearly this analysis we are talking about, okay? And then that's what I am saying for you. Then once it starts, it's about, okay, in real agile framework, you could have done in a week one thing, but how much waste within that week? One of the quantifications is that how much of the analysis you do were useful later. So if you can't really, if there's so much waste, then it's called a less efficient method. But if you really understand what is like, okay, I'm going to do visualization because, for example, partly I need to understand the data structure. And partly, I need to understand the data generation process. So that way of thinking makes it filtered, like it becomes basically, it's a hint to what kind of analysis you want to do. So the visualization is not really to enjoy or show. If that is the case, it's less efficient, because you're like, you visualize, why do you choose this one over the other? Why don't you do bar plot? Why don't you do? You're not driven by a certain outcome. And that usually means less efficient. Efficient means, okay, in the first part of my data analysis, I'm going to be very broad. I'm going to really try this and that with a goal of something, which is I want to understand the data and I want to understand the generation process. So that means it will kind of help me if I know, like, oh, is it like the kind of a binomial process, or is it kind of the collection process? Is it like, joined from multiple data sets with lots of kind of inconsistencies, things like that, So then that will shape the way the kind of the later part, which is like how you're gonna clean the data and stuff like that. So you have a clarity on, like, the data generation process is always the first thing you should understand, which basically incorporates what process is it. Is it like a binomial? What kind of statistical process generates it? Was it intentional? So for example, if something is intentional, the data is generated with some kind of intention, then that it follows a certain probability distribution than the others. So if just like randomly the data is collected randomly by people coming and subscribing and kind of checking, you can then model it as some kind of random process, such that, you kind of say, like, the likelihood of each thing being observed is similar. So some kind of like, it kind of get insight. But if, for example, if it's a survey, then that's a kind of different, because now you are asking them, and then you have to ask if this is about the sample size and all that. So that's what is called the data generation process. It allows you to know which part it is, how the data is collected, and where it comes from, how it fits, and all that. I hope that is clear. And then the next part is, of course, just once you understand, you want to go like, okay, so now I want to select some models, but I have to select some models, an appropriate model. I need to understand certain elements, because if every model depends on, like, if there is a missing value, if it's categorical, if the target has different kind of imbalance, that means like you have many negative cases and the positives are small, but also class imbalance, not only just within only, let's say, those who kind of term deposited. If they are small, let's say 1%, that's really highly imbalanced. But let's imagine not only that, within the people who are educated, then there could be class imbalance too, because like within that team, basically it's only 0.01% maybe who deposited. In that case, you really have to handle. That's where like you start really drilling in with each of the kind of class distinction and how balanced it is within class and overall the class and stuff like that. And that's where like the second parts that are coming, and you start defining which tools, which kind of visualization you're going to use to help you do that. And then there is another part which is again to help you. Okay, so you start understanding, now you understand the problem. So the second part was the problems in the data, which allow you to choose an appropriate algorithm. And the third part is to also just like, okay, within that context, what should I do? Should I transform? Is it like a huge space? Should I do dimensional reduction? Or should I do, if I have to drop, which features do I drop? So that kind of becomes like, you start computing correlation metrics and you start looking at outliers and what to do with it, stuff like that. Any question on that? I know I'm talking a lot of things. For some of you, you just understand it and it's clear. For some of you, it may not be clear.
Hello.
Hello, yeah.
Yeah, good morning.
Morning.
Yeah, so basically, there's something I think I still need to get like the workflow of this data science stuff, because the way you're saying it now, like, okay, how does this which model generates this kind of data? Like, can you share some resources with us that can actually help us to get some of this stuff? Like when we see some of these business problems, can actually, because basically the way you're just saying all these things now, it's just coming from your head, and you're just saying all this statistical stuff. Okay, which model generates this data and a lot of stuff. So I don't know if you can share some resources with us about that. That's just my own issue.
I was searching for those. I couldn't find anything that is easy in this manner. But there are technical papers that would, so it's a summary of technical, like doing these things. So I will try still, I will search. I haven't found something that is not technical to share, but probably I will share just those of the technical. It's called optimization. All of these methods are defined actually with almost always in the background some kind of technical mathematical analysis, like how to do, for example, how to do imputation has a huge mathematical background because it has to be embedded in a certain space. And so then we call it in the deep learning space, it's like the embedding space or like the representation. So, and usually explaining that sometimes you may not find the right tools, but I will try to search. But it's what I am communicating is that within the flow of even a visualization, as simple as visualization, has a very technical, you can make it technical by saying, what is it within the Agile framework? What is it that I am doing? Because there's nothing that is kind of like, visualization being useful. I mean, almost all of us will find it nice, yes, when we see nice plots, but within the business context, it may not add anything. And then if it doesn't add within the business context anything, then it's called a waste. So within the Kanban framework, it will be like, okay, you are holding on to a resource, which is time, that is not going to be useful. And that's why this kind of, all these methodologies are improving and evolving by trying to be high resolution and asking like, why do you do a certain thing you do? Of course, we don't have all that luxury to always ask that kind of question. And I don't want you to ask also that kind of question. Follow as a good strategy, and that is enough for most of the thing. What I am sharing is just exactly the thinking behind, and it kind of allows you sometimes to put together as a trade the flow. Like, why do you do visualization? Is within the CRISP-DM methodology or other many methodologies, this is because it is the first part is to understand the data generation process. The data generation process is a whole lot of things, which is about how you think, whether it's collected this way or that way. And then the second part is identifying problems within the, say, still you're doing EDA, kind of like the thing, but you're still identifying, visualizing to identify issues within the data. And then you follow the third part within the same context would be to actually then, okay, if I am going to do some selection, and it's not also linear, it's cyclic. So it's kind of, or even you do modeling and then you go to sometimes EDA to explore more and identify. So there's it's all of this. I think you know by now the CRISP-DM methodology, that's what we follow. So it's the CRISP-DM. I will share again a reference on that. It's a cyclic process. You do and you go back and then you check and stuff like that. So that's I will share on that one. But I was searching for data generation. I didn't find enough. But if anyone finds another reference on data generation process that is clear, please share it.
Hello.
Yeah.
Okay. Concerning the A and B testing hypothesis that we did. So basically, the data generation is, you can say it's a binomial data generation, right?
Yeah.
So what if it is random? Like, how do you get the concept?
It was random and binomial. So when I say random, split it into two. One is like whether did you select the sample randomly, or did you select like with a predefined names? So for example, if we went and asked, first we defined, okay, I'm going to ask X, Y, Z, that's not random. But if you say like, okay, I'm going to define only the boundary, so that means who's going to be participating, but I'm going to show randomly through like a certain way, and then people choose, then that's called random. So random sampling is one thing. And then when we say binomial, is that, okay, whether the user, when they interact, is the binomial process, are they saying yes and no, or are they saying something else? So you are trying to model the kind of the process they follow. So are they going to be yes or no, or are they going to be like sliding? Let's say if it's a slider, are they sliding? That way it's not binomial, it's kind of some kind of other process. So that random is on the sampling, binomial is on the actual action, the data, just the data point. Is that clear?
Okay, thank you very much. Yeah, very clear.
Okay. So some are, you know, without knowing many things, you can't even survive. Okay, so it's fine. But I'm just sharing with you some things which I feel someday might help you clarify some things when you read papers and stuff, as well as also just to put it in a trade. You know, it's like the story. If it's just in a trade, it gets easier. So within that context, okay. I think for the time's sake, let's continue if there's no question. And then we get into the classification and modeling, where through the visualization, now you understood. I mean, you have to go, sometimes you have to do the visualization after doing pre-processing to check that's exactly the case. But in the pre-processing part, what you are going to do is that, okay, you have encoding, you know, most of the features are categorical. And when you want to do training, you need to encode them. So that's where like you start exploring what kind of encoding you're going to use. We are one-hot encoding. If you don't know, you will read about it, but just that's one. But there's also another encoding you should try. If you remember, it's called CatBoost encoding. But that's, I will just going to mention the name, and then if anyone is interested, but you are not, I mean, I just learned about it yesterday. So again, this is not, and then you start really looking at outliers. How many outliers could you just, you know, remove them, and then the sensitivity of outliers on your model, you will check, just you write only a function to handle an outlier or not, and then later in the modeling you probably can do just call it, and then you do normalization and aggregation. Sometimes it might be useful for your model to transform some things into a new feature. So usually the way it's considered is that, let's say you have a body, like a body height and body mass, and sometimes instead of using both as two features, you can transform it as kind of BMI one feature. So that's kind of the transformation way. And then if nothing, you should try one of them. If you have already PCA, but think of a TSNE. It's a good way to visualize also multidimensional features. So as a read or comment on it, use autoencoders if you already use Keras or other cases. Maybe also Scikit might have. But this is kind of like, try one of them. PCA you already have, so it's kind of, you could also try that one. So, but just explore some kind of dimensional reduction and the result on your model. So I would say just try one of them. That is easy.
Hello.
Yeah.
Okay. Yeah. Basically, now we are going to be doing stratified K-fold and the normal K-fold. Is it compulsory we do those things, or we can just use crossbar, or we just want to test us on those two
But what
key
is,
areas?
I think, you know, the key to understand is that cross-validation, both of them are cross-validations.
Yes.
So it's about testing which one is good or not. And so in this, I think you will see one of the question I have is that what is the difference? Like, so you want to, I ask you questions to understand what is the difference. So think of like, I think it's good sometimes to use a method, but it's also important to know the difference. And,
Okay, thank you very much.
yeah, so you should, whenever, I test them, even if you say like, okay, I know that this one is probably superior and I'm going to use that and I'm not going to test that, I'm fine as long as you tell me why. So it's a recommendation. And the 3 ones I want you to at least test, but also another things like that. And then, think about afterwards, think about answering these questions, because they are key, like to be a data scientist. So just really, without that, if someone tells me a result and they can't at least guess, educated guess on why the metric is important or why a certain model is performing better, unless they are able to guess what that could be, why that could be. Answering is a different thing. It's very hard sometimes, but at least guess a little bit. Then I would feel, okay, I'm not going to be happy. So that's why I want you to at least have an educated guess on that. Okay. So yeah, I think everything else here is easy. And then the way you will write on the report is, now you will think about, just really, you are going to submit it. You should submit it, but what you submit is going to be just a PDF, but you're going to write it the way that you're going to write for a Medium press. So it's basically explaining what you do, how you go for, and providing code in GitHub. So it's basically just you flow like the kind of writing in an article. So just, if you don't know what that is, just check some of the very nicely written Medium articles and see what makes them good, especially the ones you liked, the ones it makes you understand something. It's good, and just follow them and really copy the style. If you don't know anything, one of the best thing is just find 1 or 2 or a few articles that you really liked, that was so clear for you. Copy the style. By the style means the flow. What did they do first? Just do it that way. What did they do second? Do it that way. So that's fine. That's what I do sometimes when you are starting new. So just copy a good style. Find a good thing and copy the style. And I think that's all what you need for this week. Is that clear and everybody is on the same page? Hopefully the silent means yes.
Yeah, Bawal.
Yeah.
So during the previous few weeks, I was having trouble compiling my report, and it would really help if you can provide further instruction on how to write the report and also some sample files.
Yeah, so in this case, it's not a report. It's going to be a Medium article. So I think I will try to share some of my favorite ones maybe. But what I'm going to say is that really copy the style. So just find an article that you read, in towards data science, whatever, and then just what makes it great, and just use that one as a template. So it's kind of like, or if you search in Google, what is a good Medium article format, that you will find. But I would say almost always, it's better and easier and good if you start from the article you like, the article that makes you understand, because then you can also write it clearly. So that usually reflects your own interest. So it's like, not all of us have the same thing. Some people want detail, like, okay, do this, do that kind of approach. And other people kind of like logical connection and stuff. So this is an open article, so for a public. So it has different styles, but I would say my really strong recommendation, remember the ones you liked when you read it, was so obvious and kind of like you said, like, that was really great, like this was a nice article, and then just copy and then look at it, the structure. What did they do? Usually the flow is like this. They kind of do motivation, right? It's like they kind of motivate why something is useful, why this article should be written. And then they follow about other kind of review something, and then they give you breakdown the methodologies and stuff like that. So almost every writing is like a story where we have to motivate, convince people it's the best thing in the world. you should really know. There is nothing else you should know. This is all you should know kind of way. And you try to convince people that this is so important, and without this you can't, even your life is sucks kind of way. And then you try to present some kind of like, how other people do it and it's crap, and why the way you do it is amazing. And then you kind of present the way you do it, this amazing thing. And then you kind of conclude, of course, like it's not great, but that's life. And then that's conclusion. So I think that's the 4 major flows, but I think there are many ways within a lot of creativity there. So I would say just take, and I will try to share also, everyone else, share your best Medium article so that other people can see and read. So yeah, let's have a trade in Slack, sharing the best Medium articles that you enjoyed reading. Yeah, Patrick?
Hello, please can you hear me?
Yes, we can hear you.
Oh, good. So there's a part in the tax document that mentioned about the project structure. I really like that part because it's one of the things that I've also been trying to achieve myself. I would like you to just talk briefly on it, the project structure. I mean, the part where it said your GitHub folder should at least have the following requirements: the txt main.py, beta.py, loader.py, and notebooks.
Right. Do you see it? Is that this one? Hello, do you see it?
Yes.
Yeah. So, okay. So if you can mute it, then yeah, great. So this is the structure, at minimal structure we expect. This is basically the README is the README, but README should be, it should tell what the project is about. And there are many, if you look at many other packages, just it's all how you define it is clear, but it would be nice to also the README to reflect how to run the main. So basically, like it describes what is in the main. Basically, you can copy this even, right? So what is in the main, what is in the data, what is in the model, but then you should use argparse. Like in the main, it's going to be a script. The argparse, like I'm going to or you can do argparse or fire, the fire packages. So actually I prefer the fire package, it's really great. Or there is also actually, it's called Click. These are, but fire is my favorite recently, so I'll just do that because this is a way of converting any code into any class, whatever, into a command line interface, basically. So that's and the most easy way to do it. Okay, so the main basically becomes your code, main code to run to do something. You can just like Python main.py, pass arguments as like dash, I don't know, data file or the test file, something, and then it should run and produce. Output is equal to something. So this should be basically the entry point to the entire code. So it just encapsulates, it's called a wrapper. It wraps everything that you do. And the data py should basically contain all of the kind of the pre-processing you're doing in Python. So after visualizing in Tableau, you know what things needs to be done. So that's the pre-processing part. So you can have plots inside them, but the main part is at least you should have all the pre-processing, the kind of outlier removal, whatever you're going to do, class imbalance handling, whatever, missing value handling, everything just that related. Given the data, there should be a class or a function. Given that, it will just return from here. Then you will return just only a clean, nice model-ready data, and then the model takes that one and has many functions and maybe classes that will just do the modeling, and basically just, so all of that you probably first could develop it in a notebook, and only finally when you are happy, just put them into a script. Okay, so it's almost always, you can use here, for example, use the write file write to file. I mean, check that. I mean, I don't know, it's write to file or file write magic. To write in Excel to a script. So there is a way, just write file, I think. So in notebook, in a notebook, like you will have this write file just in the beginning of the cell. If that cell contains, you know, all the Python codes in that cell will just can be converted to be written. So you can just say write file, like, I don't know, data.py, which just basically make it that cell, if that contains all the pre-processing codes or functions, it will just write it to the thing. So just check that. Okay, hope that's clear. Great, everything clear?
Yes, thank you. So, two things. First, just to demonstrate my understanding of what all you just said, the reason why we have this project structure is, number one, to make the project at the end of the day to be installable. Like, if somebody else can install the project. Then number two, to, rather than having all our classes or functions, the functions we're using defined in the notebook, we'll just import them from those modules, like the main.py, data.py, import them from those modules and import them to the notebook and use them. If I'm very clear on what you, if I'm very clear on what you said, okay.
I think that's very true. And also, more than that, the same function now, you should be using them when you compute.
Sorry, I didn't get that, please.
Because, can you mute it? Yeah. So the same functions, whatever you use, you know, you're gonna, I'm assuming that you are using your previous week's codes to do things. Otherwise, you are not doing great. So, and this one kind of formalizes all those kind of codes and makes them nice, such that you can use it next week the same way. You can use, you know, if you write it nicely, you can use it next week as well, and the week after, and also when you compete. You don't have to write any code anymore for a particular thing that you are doing, right? So it's kind of making it modularized in such a way that you can reuse your code. But as you said, other people can use it, you can use it later. Yeah, it's a lot more making it modular. And also, after that, it will be easier if you want to install it. But even without installation, this can be just, you can convert by just adding -- init in the main folder, then you convert it into basically a module. But that's where I was saying also, you could also actually consider writing, instead of like one data.py, you could actually say data folder, where in that data folder, you kind of actually write each piece differently. So you'll have many files within them that are actually becomes like the thing. So yeah, it's your choice. You can make this thing a module folder or a module just script. So but I would say this is the basic minimal structure, and this way you can over and over use it in time, as well as anyone can use it. And the main wraps whatever it did, the main wraps it. And you may add even utils function, another utils.py, where anything that doesn't fall in the data and the model, you can just put it there. So like, I don't know.
It's not bad.
Any code. Data .py, and that's time things, whatever. But I mean, you don't need it. I'm just saying that's one. Okay, go on.
Okay, thank you. So, I don't know, questions are just popping, but I really want them to be answered rather than in Slack. If so, I don't know. Should I just ask them all of them now? Then you answer them one by one, or I ask them you answer all?
Yeah. So I mean, I don't know if I understand. So you can add this question, especially if there is anything in or they just do one more.
Okay. Okay. The question I want to ask, as a follow-up on this, we said something the other time about we being able to use, like, the code can be run from the command line and to accept input from the user or anybody who is running it on the command line. I need more clarity on that, please.
Okay. So, you know, like the main function is gonna need data input, and it's gonna write file output, like some kind of files, and you can write those things by hand inside the code, or you can make it take those things from a command line. What I'm asking you is just to make that one changeable. That means to be passed from the command line. Is that clear?
Understood better. I understand. Then secondly, this actually, okay, let me ask the third one, because that one has to do with this tax. There's a part in the requirement a bit in this place. I just want to quickly check it.
Is that the requirements of the text?
No. The task requirement is similar to be trying to locate them, but okay, I think I can locate it now. Probably I'll just ask later. But there's a particular challenge. My team faced in the last challenge. So when we loaded our model, we built a pipeline in our model, then we loaded it into the Flask app. So when we try running the model on the Flask app, we're getting this error. So there was a particular class that we defined for pre-processing, and we put that class in the pipeline. But when we pickled the model and put the model in the Flask app, it was throwing up an attribute error that the model, it could not get that particular class, which is an attribute of the model, for the model to function. Something like can't get attribute error, and it was a bug that really limited us on what we could do. In fact, when we did a lot of research on Stack Overflow, we couldn't find meaningful answers. We saw some answers like we have to do custom pickling, and also I want to know if it's something you've experienced or something you know about that you can talk about.
Yeah, I mean, I without particularly knowing the problem, it's very hard, but it's most likely that it was not imported and not included in probably the pickle. So that's why of course it cannot find it. It was probably dynamically being loaded. And if a quantity is dynamically loaded, it means in the environment you are running, that thing has to exist, but probably didn't. Therefore, that's what you find an error. So it's always like whenever you have that kind of interportable issue from one system to another, the best to find is what are the elements that are dynamically loaded and what are the elements that are loaded in the memory. And anything that is called that needs to be dynamically loaded should be available also in the other environment. So that would be the way. So that's why Docker and stuff is useful, because or requirement files, if you have the requirement file, you can just install them also there, and then you will have exact similar environment.
All right, thank you.
Great. So Deborah is here. We are about to finish, but at least the good thing is that she is the one who who's the responsible for this week's challenge, and she designed the challenge. So maybe Deborah, do you want to say anything? So we were discussing about the different elements. So, but if you want to give an overview, and then I have to leave soon, but just let's yeah, give them an overview and what's within the week, what you're gonna, when you're gonna be available and stuff like that.
Okay, hi everyone. Good morning. I guess you can all hear me. Can you hear me?
Yes, we do hear you. Yes,
Okay.
yes, we can hear you.
Okay, so my name is Deborah Doma Kanubala, and I'm just finishing up with my master's program with the African Masters in Machine Intelligence program. Machine Intelligence program in AIMS, Ghana. So I'm really excited about this week's challenge, and it's just basically on a classification, and you would have to build a predictive model to classify term deposits. I guess probably Yabel has already shared the link with you, so the details are there. Hopefully I would be meeting you on Wednesday to take you through a starter notebook that I prepared, and I'll be happy to answer any questions that you have. So maybe we'll leave it to Wednesday when we meet, then we can talk more. Yeah.
Great.
So I don't know. Yeah.
Thanks, Deborah. And yeah, so if you have any question with respect to like the challenge, the kind of the concept behind or why and use cases, whatever, anything, you can just reach out to her, and she will answer. Okay, so I see some questions, Patrick.
Yes, please. My last question. There's some models you made it compulsory for us to use. I would like to know why you made it compulsory for us to use those models. Just
No, it's because they were, when we agreed, they were kind of performing better, at least from people's experience, and we need 3. And
I see.
From clarity perspective, as well as also from people's experience, that they work better. So, but yeah, you can definitely, if you think that is really not true, and the first is one is it's because it's mostly used, and the third one is because like one person who is said like they really work well, and an XGBoost is something you should know. So, but there are XGBoost implemented in a number of other places. So Scikit has one, but others have also. So you can also use some other things. But yeah, that's so the rest. But also some of them, for example, random forest, whatever they might not be appropriate sometimes or whatever. Just so these are one of our reasoning, but you are very much welcome to try and actually find other models that really work for this data. So that's
Thank you very much.
great. So another one is okay, yeah. Yeah, Deborah, you are in the Slack group, right? In the students or not? Okay, I will add you. Okay, so I see you are muted, but
Oh, sorry, I'm not on the one with the students.
Okay, so then we definitely will add you. I will just add you right now.
Okay, all right. Thanks.
Okay, so great. So with that, probably we'll stop, but she will be probably now in Slack, so you can ask her directly, just hopefully, right? Just leave for the next couple of minutes. Awesome, guys. Thanks. And I'm just going to stop recording.